My name is Suresh Dhaniyala. I'm the Bayard D. Clarkson Distinguished Professor in Mechanical and Aeronautical Engineering at Clarkson University. Um, so I do research in the field of air quality, climate change, and just environmental issues and energy. I am originally from South India, and um, I don't know if you can cut that. I'm originally from South India, from the city of Chennai, and I remember growing up in the 1980s and 1990s when I was going to school. I would open the big newspaper there, and it would say right in the front of the page when it's a warm summer day that the day is going to be hot, and you'd know that because the headline would be Mercury crosses 100. It means on that day the temperature has gone above 100 degrees, and that was a newsworthy item that had to be reported because that only happened about 10-15 times a year that the temperature would cross 100 degrees Fahrenheit. I go back now and I check the newspaper. I have not seen a single report of temperatures of them recording when the temperatures have gone above 100 degrees, because this now happens nearly for about 50 to 60 days a year. And that is a big change. That's a big change in the fact that going above 100 degrees was an infrequent occurrence to something that's now become commonplace during summertime. But that's just anecdotal, that's just what I remember from my time back there. So about 3 years back, I was giving a talk back home in Chennai, and I thought I just wanted to check on this data and see is what I'm just remembering about the temperatures and about the climate there, with the changes in the climate there, which is just what I just know from reading newspapers and visiting briefly. Does that match up with data? I went down. I went to the NOAA website where they have temperatures from sites around the world, and I downloaded the data and investigated the number of days where the temperatures went above 100 degrees. And lo and behold, that was indeed true, that before 1960s, there were less than 3 days a year on average when the temperatures went above 100 degrees Fahrenheit. And now it's about 60 days when the temperature goes above 100 degrees, 60 days a year. And so this increase in temperature, this increase in the number of days when the temperature is this unbearable temperature where it's above 100 degrees Fahrenheit, is not something that is just a figment of my imagination. It is indeed true. It's backed up by data. I've also done other investigation to see about water. One of the things I remember is that we would have these sustained periods of rain in October and November, part of the northeast monsoon. And recently, the rainfall patterns have been haphazard. There have been reports these floods that have happened that are once in a century flood, and then followed by droughts and so on. So I looked at the data to see what's happening with rainfall. And again, the one big change that I've seen is that the average rainfall has actually gone up in the last 40 years. But what has changed is that previously, if rain was spread over 15 to 30 days, now it's spread in maybe 5 to 10 days, or 12 days, or 15 days. So the rain is coming in a much shorter time, and you're getting on an average more rainfall, but in a much shorter time period. And so the groundwater is not replenished as much, so there isn't as much water available for people to drink. So climate change, from where I am back home in India, is real, and the impact is right now. I mean, it's being felt right now. It's being felt with these very hot days that sustain for a longer time period. It's being felt with less water being available for people to consume, and it's being felt with health impacts. And in talking to local researchers who are studying health impacts of people who are working there, what I learned was that people who are working in the fields are, and they're working sometimes 8 hours a day in the field, and a lot of work in the field, agricultural work happens with manual labor in places like southern India, and that means this temperature has gone up 2, 3, 4, 5, 10 degrees at certain time periods of the year compared to 50 years back, is having a major impact on these people who are spending a lot of time outdoors. And one of the detectable health problems has been an increase in kidney disease, especially amongst women who are working out in the field, who are not recognizing the fact that this increased temperature is making them vulnerable to dehydration and resulting in this kidney disease. So this is a problem that is being experienced right now there. And as we teach climate change here in Clarkson University, we are having students recognize and go and discover for themselves these changes that are happening in their hometowns, for example. This could be North Country, this could be other parts of New York State, or anywhere in the United States, for example. And what we're finding from our students who are going out and exploring data, like I've done for my hometown, is that there are similar rises in temperatures. Pretty much any place in the US we take. The students go download data and they see that there is this increase in temperature. And we emphasize, so in addition to their discovery of data of what's happening, we then provide them some of the background of what's happening with respect to climate. And so the science of climate change is basically fairly well known at this point. We understand that there are certain gases when we put out in the atmosphere. These are what we would call greenhouse gases, are efficient in absorbing long wave radiation. That's the heat that's coming out from Earth. And if we had more of these greenhouse gases, it's like increasing the thickness of your window pane. If your house is getting heated up by sunlight because you've got these windows through which sunlight is coming in, if you had thicker, more insulating glasses, we can retain more heat in the house. And similarly, our atmosphere has this glass pane, which are these greenhouse gases like carbon dioxide and methane. And as we increase these greenhouse gases, we can absorb and re-radiate this long wave radiation. We can heat the Earth more efficiently. And so that science is well known from laboratory experiments, has been known for hundreds of years. What we now know is from measurements that our activities have resulted in a significant increase in these greenhouse gases. And these greenhouse gases, the increase in the greenhouse gases in the atmosphere cannot be explained with any other sources out there other than our activities. And we know from computer simulations what impact continued emissions are going to have on a global scale. And remember, when you hear these terms like 1.5 degrees centigrade that can increase, that's when we think about these numbers, these temperature rises that can happen globally, as 1.5 degrees or 2 degrees or 4 degrees that we are hearing, they're all based upon a combination of good laboratory experiments that tell us how much energy is absorbed by these greenhouse gases, with computer simulations that take in the best physics and chemistry that we know to determine if we inject all these gases, these greenhouse gases into the atmosphere, what is the net energy balance that the Earth will experience, and correspondingly, what sort of temperature rises would we see. And so this is backed up with a lot of science, and so we teach some of the science in our class, um, and um, and we look at what sort of policies uh, might be implementable to reverse it. So as much as we know climate is changing and it's happening because of human activities, uh, this is not a reason to not do anything. I mean, there are activities that the changes that we can make in our lifestyle, in our consumption patterns, or in our technological use, that can, if not reverse the changes, it can at least cap it. Could we limit the amount of these greenhouse gases we put in, so we can limit the rise in temperature. And again, the impacts that are being felt right now in places like India and parts of Central America with respect to this kidney disease and so on, may or may not be felt in here because our temperature rise is going to be different. But we are going to feel an impact of this one way or the other, with respect to the with respect to agriculture, or with respect to economy, or with respect to just our way of life here. And yeah, so this, that's my story here.